Hello and welcome to C++ Weekly. I'm your host, Jason Turner. I am available for code reviews, contracting, and on-site training. In this episode, I'm going to continue my series on features that are added in C++20, and this is going to be about 4 init expressions in C++20. So I have my trunk build of GCC that I'm using here, and I'm going to put the compiler in 2A mode. And if you want more information on that, go back to some of my other episodes about C++20. So let's go ahead and look at our ranged for expression. We're going to start with simple ranged for loop from C++11. And I'm using C++17's class template type deduction here. If you noticed, I did not have to specify any of the template parameters. And this is what a ranged for loop looks like in C++11. Now, for something like this, we should use an algorithm instead, but I'm going to demonstrate some possibilities here. So we can see here that we have summed the values 1 through 6, and we are returning this total from main, and it gives us 21 at compile time. This is something that the compiler can easily optimize, and this shouldn't be any surprise to us. Now, C++20 adds the ability for us to do some sort of declaration expression at the front of our ranged for loop. So we could do something like this. And now we have created a variable called position that is scoped only for our for loop. And we could do this. Now, if we were so inclined, we could do something like weight the value based on its current position. So this kind of gives us some ability here for having both a clean ranged for loop and keeping track of the current position. And as you can see, the compiler was not able to optimize this away, but that's okay. If we reduce the number of elements in the array, it may be able to. There, if we have 3 elements, it's able to unroll the for loop and tell us that the value is 8. But that's not really the point for this example. This is the point right here, is this for init expression. Now, the real reason that this exists, I mean, this is one way to use it, but the main reason that it exists is to avoid lifetime issues. Now I'm going to give a very simplified example here. If you watched my previous episode about the one feature that I'd removed from C++, you might be wondering if this is safe, and it definitely is. The standard array is a type-safe wrapper around a C-style array. We can return this from here. We have questions. If we were to do something like this get data right here, have we done something that is safe? And to test this, we'll have to take out this code that relies on this position. So we see that 6 is being returned, but we're wondering perhaps what happens with the result of this function. And it is actually safe in this case, but if you have a function that returns an object that you then call this like get data on, for example. So if we have something like this, where we have a function that is returning some other object, and then we're trying to access the data of that, and we have these nested calls here in our ranged for loop, we have object lifetime issues. The thing that has been returned by getS is no longer valid by the time we get, well, when we make our get data call, this is still valid, but the thing returned by getS is no longer valid. So this data up here on line 4 has been popped from the stack. That has been lost. And we can see here in the code that the compiler is just adding random memory locations together effectively. And I switched to Clang along the way to get some of these results so that we could see what the compiler is doing. If I go back to GCC, we can see that GCC is still doing the same thing here. So this is where ranged for loops really come in handy with our for init expression. If we were to do something like this, then it becomes well-defined behavior again, because we have used our for init expression to keep a local copy of the thing, and then we are doing our ranged for loop over it. Now, I will fully admit that this syntax will take getting some used to, and if you were to put your compiler back in C++17 mode, the error that you get, let's see, if you have a compiler that does not yet support this, is variable declaration and condition must have an initializer. Like it thinks that you're doing a regular C-style for loop, but you have basically left off a condition for it or something like that. So you'll get some weird warnings if you try to do this on your compiler that doesn't have support for it yet. And it's coming. We've got it in GCC. So I hope you liked this little preview into things that are coming in C++20. And be sure to subscribe, give this video a thumbs up. Thanks.